Hello and welcome. In this video, we're going to talk about perhaps the most important library if you're dealing with data, and that's known as Pandas. Pandas is super popular because it resembles the kind of data that you get from spreadsheets. Essentially, that's called as structured data, which comes in row and column kind of format. So we'll be talking about Pandas. We'll do all the basic stuff here. So this video is totally beginner friendly. We are not going to cover very advanced concepts here. It is meaningful for people who are learning how to work with data in Python. And we'll be covering most of the basic stuff related to Pandas in this video. If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. These are the videos in the right sequence, which will give you thorough knowledge of the subject. Please share it with all others who might benefit. Let's get started. So to begin with, we are calling two libraries. Of course, we need Pandas with an alias PD. And this is not mandatory. You can give it any name, but it's more of a convention that Pandas in short is called PD. And then we're calling another library because we'll get data. Data will have some numbers, and that's NumPy, and we're calling it as NP. Let's begin by importing these two libraries first. Now, we'll learn how to create a data frame and how to read data frames. So let's first learn how to create data frames. The first method is that we can create a data frame using dictionary with the help of lists. So if you've watched our earlier videos, you'd know what are different inbuilt data structures. Dictionary is one of those, and it is a key value format structure. For example, here, these column 1, column 2, column 3 are the keys, and these lists which contain some values, we've kept it very simple, 1, 2, 3, 4, 5, 6, 7, and alphabets. And another important input that we've given through column 3 is a list which has some strings, which actually has a meaningful message for us. All lists must be of the same length. So if you're trying to create a data frame like this, and let's say for the column 1, you choose 8 values, and for the column 2, you choose 5 values, it would not work. Each list should be of the same length. This is a dictionary put under the curly brackets or flower brackets. And when we give this dictionary as an input to pd.dataframe, where are we getting it from? This data frame method is coming from the library called Pandas. We imported it as PD. So when we give it as an input here, it will form a data frame like structure. Let's see. So you see, this is a standard row column structure. Rows are identified by these values here. These are called indices. Single value is referred to as index, and these are columns. And inside the data frame here, what we have are called values. So we just generated a data frame using dictionaries, particularly with the help of lists. Key and values. Values were passed in the form of a list. Please note the keys in a dictionary have to be uniquely identified. Values could be repeated. For example, if it's A, B, C, D, I write another A, B, or C, or D, it would not be a problem. But if I write another column 1 or column 2 or column 3, then becomes a problem. The keys are unique in a dictionary. Next is, we'll use a combination of a list and arrays. So if you've seen our videos on NumPy, you would know that we have an option to generate values using various random methods available within NumPy. So let's say we're creating another data set, which is through a dictionary. Dictionary is called data1, where there's a column called employee ID, which has these values, 5 values. Then there's a column called age, and for this, we did not pass a particular list. We just chose to create some random values using NumPy's random module. Within that, we are using random integer. And what is the instruction we are giving? We are saying these values have to be between 20 and 30, both inclusive. Remember, in NumPy randint, the upper value is not counted. So when you pass 20 to 31, it's going to consider values from 20 to 30. And how many values it's going to give us? 5 values. Remember, the length has to be same. Since we have 5 employee IDs, we are generating 5 age values here. And we are also mentioning sites specific to these employees, which are represented by, let's say, A, B, and C. Again, 5 values. And we can just pass this to, once again, pd.dataframe and look at our data. So this is how some data has been generated. We'll try to perform basic operations with simple data sets like these so that you can actually see what kind of changes are happening, and it's really easy to register in your mind. We can also create a data frame from a list of lists. So what is a list of lists? So like you can see, these are small lists, name of a person, and let's say age, name, age, and these have been collectively put under a list. So this is a list of a list. And if you do it like this, we specifically need to pass the names of the features. For example, we have to mention what does this value represent. So let's say we call it a column called name, and the next value is age. So we have to mention what are the columns. pd.dataframe we can mention this. In fact, there's an option for us to customize the index as well. You can check that through the documentation. But let's just generate this one right now. So we have our data frame, which has these names and these H values. Once we create a data frame, we might want to use it later. At times you're working on a data, you have to give it to someone else for some other task. So what you can do is you can always save it. What we are doing is the df data frame that we created, the first data frame using a dictionary, we are saying we want to convert it to CSV, and this is the name we want to give it. Notice, if you do not give this parameter, which is index, if you don't set it to false, it is going to add another column to your data to a CSV file or Excel file, which will be an unnamed column with just these values. And this is not useful. In Excel, we can, of course, identify each record with a specific ID. So we don't want to pass that, and that's why we are giving it like this. Similarly, let's say the second data frame that we created using an NumPy array, we want to save it. We're giving it a different name, and we're calling it Excel6 with the extension and index. Index false would again ensure that these values, the index values that we had here, will not be saved. Fine. So when we run this, where is this going to write it? It's going to write it to the current working directory. Let's just run this. Can we find out if we have these data sets now? Let's see. You can see data CSV and data1.xls6. Those data sets have been saved here because we're using Google Colab right now. Now, let's say you want to load the data and want to resume working on it. You can, of course, use read CSV and point to the current directory. Because we already have this pointed to the current directory, we can directly read it. If not, then you may have to mention the path where the file resides, and it'll be able to then figure out. Let's just run this. So it has read the data frame, exact same data frame that we created. We saved and we loaded it from there. Once again, if you want to load the second data frame, let's say it was an Excel file, we can use the read Excel method. So previous one was read CSV, and this is read Excel. We are just loading it again, and this is how it comes up. Let's move on. We have some very basic methods associated with Pandas data frames to quickly inspect the data and see what all it contains. For example, it's very customary whenever you read a data, you first few observations using head, or last few observations using tail, or randomly sample some observations using dot sample. So let's see all of these. So let's say when we do head here for the first data frame, it's going to give us the first 5 observations. This can be customized if you want to look at 4 observations or 10 observations, and you can see 4 observations now, index 0, 1, 2, and 3. Likewise, let's say you want to check the last 3 values, you can do df.tail3, and this will give you the last 3 values. Similarly, if you don't want to just go in an order, you want to pick some values randomly, you can do a df.sample, and you can write the number of observations that you want to pick from the overall data. It may not necessarily pick them in sequence. So let's just run this. So as you can see, it has picked the index 6 first, and then it has picked up the index 5. Totally fine. We also have a method called info, which gives us concise information about the data frame. So what all does it tell us? Let's see. First thing it tells us is that how many indices we have for the rows. So it says 7 entries are there. These are from 0 to 6. Then it says we have total of 3 columns in our data frame df. And it also tells us for each column how many non-null values are there. If there would be a missing value, it will adjust the count accordingly. For example, if column 1 had 1 missing value, it would show 6 non-null entries because 1 null entry is present. And it also shows the data type of the variables. Also, finally, if you have many variables, when you're working on large data frames, you'll also be able to get the count of different data types. So there is 1 integer variable and there are 2 object type variables. Integer variable, as you can see, is this one, which has all the numerical values. And object variables are the one which have categorical variables or strings in them. If we check the same information for data frame 1, this is how it comes up. It says it has 5 entries, index 0 to 4. It has 3 columns again, and this is the nature of the variable. This one has 2 integer columns. One is an employee ID. Other is the age. Remember, we generated it using the NumPy array. Then we have a method called describe, which helps us get a quick descriptive summary of the variables. So if we don't pass anything inside describe, we apply it to a data frame, it is going to give us a summary of the numerical features only. Let's run this. So there was only 1 numerical column in our data frame, which was a sequence of numbers from 1 to 7. It's just trying to find out a 5-number summary on that. It's trying to tell us the minimum value, the maximum value, and a couple of percentiles in between, 25th percentile, 50th percentile, and 75th percentile, plus the count, the mean, and the standard deviation. It's a quick descriptive summary. And we've covered this at length in our descriptive statistics videos, but just for your reference, this is how you can get it. If you want to see more information on categorical variables, because right now it's by default showing us only the numerical variables. So can we do it for categorical variables? Yes, we'll have to pass a specific parameter which is called include, and we have to mention that we want to get it for object type variables. So if we click on this, it would look different because for categorical variable, you cannot calculate an average or standard deviation. It's a collection of strings, right? So it's going to show us some information, which is like how many categorical variables are there, how many unique categories are there for categorical variables. Looks like in our data so far, we did not have any repetition. So it's showing all 7 categories were unique, and it's showing which is the top category. It's right now picking up the first entry basically. So it's just showing that. But if you have some repeated entries, it'll show you the mode and the frequency, how many times that values repeat. Also, if we change this input from object to all, it'll show these two together. It'll show the categorical output as well as the numerical summary. Let's see what happens. So you can see these are the categorical variables, pretty much the same summary that we saw here. Of course, for numerical variable, it doesn't show the unique categories and mode and frequencies. It shows the summary here for categorical variables in the first part. And for the categorical variables, it will not show the numeric summary as you have for the numerical variables. So you can see it's kind of different. For categorical variables, this piece shows a lot of nans because you can't have this summary. And for numerical variable, this piece, which is available for categorical variables, shows nans. And if this is not easy to read, if you are not comfortable reading it column-wise like this, you instead want to look at a transpose, which is swapping the rows and columns. You can do that by just adding .t here. Let's see. So when we added .t here, it just shows for each column what these values are. We already have the information on shape, but if you read a data frame and you, without getting into the nature of the variables, etc., want to quickly understand how many rows and columns are there, you can simply use an attribute called shape. This dot shape will tell us how many rows and columns we have. It returns a tuple. 7 rows and 3 columns is what we have. Now, there are 3 important attributes of a data frame. Like we discussed, it is something that has rows, columns, and values in it. So if we want to access these independently, we can do this. Let's say we do a dot columns. It's going to return a list of featured names that we have in our data. Column 1, column 2, column 3. While working on a data frame, which is pretty large, you may not exactly remember how a column's name was written. And remember, all of this is case sensitive. So if I try to mix match the cases, something that was written in uppercase, I change it to lowercase, it is not recognized the same way. So a lot of times when working on features, if we want to call a specific feature, we first want to see how does it appear in the data. We can quickly do df.columns and it'll give us the list of features. Likewise, df.index will give us the index values. In our case, it was a simple integer sequence. So it is going to give us that starts at 0, stops at 7, and it has a step size of 1, which means 0, 1, 2, 3, up to 7. Values is going to return an array. This represents the information that's there inside the data frame. So rows and columns would form the skeleton of the data frame, but what's filled inside the data frame would be through values. And this would be a NumPy array. As you can see, it's an array. It shows us what these values. Putting these 3 things together, we obtain a data frame actually. If you want to quickly check the data types, what are the different data types that we have? Because a lot of our data visualization and treatment depends on the nature of the variable. It's one of the first things. And we've covered this at length in a separate video already. So if you want to get better understanding of data types, you may refer to that video. But this will just tell us what's the nature of the variables. So we have integers and objects. In a way, if you see a lot of this information like this, dtypes and shape, came clearly through info as well. So it's up to you what you want to use first. Let's say you're referring to the categorical variables and you want to see the unique entries in the categorical variable and how many unique entries are there. You can always use .unique and .nunique methods. Let's call the data frame. And here, if we just check how many unique entries are there in these categorical columns like column 2 and column 3, we can check that. Notice we are using a print here. Why? Because if we do not write print, it will only give the output of the last line of code. And if we do print, it's going to show both the outputs. Let me show you. So see, it's telling us 1, 2, 3, 4, 5, 6, 7, which is the column 1 has these unique entries. It is more meaningful for categorical variables, so we can even change it to column 2, and let's say column 2 here, and it's going to give us that list. It's not that useful for numerical variables if the variables are continuous. In our case, the data was limited, so we could still manage, but generally we'll use it for categorical features. And nunique is simply the count of these unique values, right? Now imagine if I would have not written this print here, and if I just simply write this line and this line, then what will happen? You're seeing this as an output, the list output so far, right? But if I run this code now, what happens? You simply get one output, which is 7. Essentially, it's only displaying the last line for us. Let's take the data frame 1 because it'll have something different for unique. So let's say we refer to this column site. And in the site column, if you see, there are 3 sites, A, B, and C. And C has been repeated. A has also been repeated. B is uniquely present. Now, when you check unique, it should display A, B, and C, because these are the unique labels that you have. And any unique should display 3. That's how it is, right?